Thank you.
I like to sit at the end.
Take your seat.
Right. Get sit here.
Sure. Okay, everybody settled. All right, everyone. So this is a panel about UNS. We've got a bunch of great experts here. Just want to say a few words, but maybe I'll let everyone introduce themselves first. My name is Dylan. I run technology partnerships here at Tulip. Been at the company for 7 years or so and seen a pretty amazing rapid rise of technology in manufacturing, and here to share my experience. John?
Thanks, Dylan. I'm John Harrington, the Chief Product Officer and one of the co-founders of HighByte.
Hi, everybody. I'm Harry Greywall. I'm the Director of Partnerships, Cloud and Strategic SIs globally here at Litmus.
Hi, everyone. My name is Ravi Subramanian. I'm the Director for Industry Solutions at HiveMQ.
And I'm Walker Reynolds. I'm President and Solutions Architect at 4.0 Solutions and the lead educator at IIoT.University.
All right.
And the founder of UNS.
And the grandfather.
The grandfather of UNS.
Yeah.
So we're here to talk today about Unified Namespace. I'm sure it's a term that many of you here have heard, but there isn't yet an O'Reilly book or a For Dummies guide. There's at least one Discord channel. There are many philosophical corner conversations, a few that I've had today. And we'd like to take this opportunity with this great panel to bring this topic to the main stage, literally, for all of our benefits. So I'd like to start with a question for the granddaddy of UNS, which is, if that's okay, I call you that.
By the way, this is going to be how this panel goes. We're going to have fun with this. It's the last panel of the
Exactly. Thanks.
Yeah, we have been
Setting the tone.
so please bear with us.
Can you take a stab at succinctly explaining what is a UNS?
So Unified Namespace is an architecture. The reason there isn't a Wikipedia entry, although there is in Germany, the reason there isn't a Wikipedia entry for the definition of UNS, that was by design. It started out as an architecture to solve my own problems in a salt mine in upstate New York in 2005. I wanted a single source of truth for all data and information for every event in the business. I wanted something that I could give to end users and supervisors and managers and tell them how the data is organized so that they go find what they're looking for. Mm-hmm. That's what it was for, semantic hierarchy. So UNS is an architecture that is semantically organized. Generally, ISA 95 Part 2, enterprise site area line cell, and then it's broken down into informative namespaces for consumers, functional namespaces for business functions, which makes up about 80% of what you see in a UNS, and then descriptive namespaces for definitions. UNS, first and foremost, is an architecture, but it is also the hub upon which smart things in the business interoperate with one another. They publish into a unified namespace and they consume from. And smart things start with people, with operators, and that's actually where UNS came from. The first one was built with dynamic data exchange using Microsoft Excel and Data Highway Plus and RS Links from Rockwell. Okay.
Very cool.
If you want to see, real quick, I want to test something. So if you guys want to take out your phones, all of you don't have to because we'll probably blow the server up. But if you go to virtualfactory.online, when I looked at that original UNS example that when Natan was speaking earlier, your UNS example, it gave me the idea to show you what a UNS is. So there's actually a factory, a simulated factory publishing to virtualfactory.online. You can navigate through, you can see the production lines, you can see the S88 endpoints, BigQuery endpoints, dashboard endpoints. But if you want to see a UNS, you can go to virtualfactory.online, and that's the only thing that's there right now, and you can just navigate through it. That's what Unified Namespace is.
Cool. Anyone else have a comment on
It's a tough act to follow.
definitional?
Because you covered everything. But I think like the key thing that one of the things that Walker mentioned and based on the conversation I had with customers and prospects, what does a unified namespace do? I have a MES application. I'm already talking to databases, or I have like a ERP application. I'm talking to the sensors. So why need a UNS? I think what he said is like that ability for like many of like the sources to talk to many of the other data sinks or vice versa, right? That single hub of all of the business data that enables you to have that communication. That is, to me, is like a key takeaway for Unified Namespace, apart from the fact that it's a single source of truth, and it's where all of the business, if you want to look at a snapshot of what your business is doing at this point, that's a Unified Namespace.
Right now. Every time you look at a UNS, that's the business right now.
Right, exactly.
Slice right now.
Exactly.
And I think the key is, like, why do we need a UNS?
Yeah.
And the challenge is, if you don't have a UNS, you're going to 5, 10, 15, 20 different applications to get that. And you can't just get that information. You can see it on a screen, but it's all locked up in that application. And what a UNS does is it allows people to pull that data out, subscribe to that data, pull it out, and bring it up in whatever application they want. Bring it up in Snowflake, bring it up in Tulip, bring it up in Excel, so that they get access to the data right now and can use it and can put it to use. And tomorrow they need a different set of data. Or in 15 minutes they need a different set of data. And the key is, when we're dealing with that sort of agility, we need a single place that we can subscribe to the data, get access to the data, and work with it. And that's what, you talk with people in manufacturing plants and they say, yeah, we have all the information, but it's going to take me a month to get a report out of IT. And that's one of the barriers that we're breaking down. And I think the other barrier that Walker said well is, we're organizing and we're structuring data, and then we're organizing it so that anyone can go in and find what they need.
Right.
And it's not just structuring data and landing it in a database that no one knows where to get it. It's organizing it into that database, which is why we use the ISA 95 structure. But so it's those combinations that make it so powerful.
With databases, you have to teach schema, right? In order for you to extract, the first thing you have to learn is how the schema is organized. The larger the database becomes, the more you have to understand the schema. If you don't know ERD, if you don't know how to look at relations, and if the DBA who designed the underlying schema didn't know what they were doing, those are barriers for unlocking potential in businesses. The idea was, and we talked about this earlier, Mark and I did, he actually called it organizing files on your desktop.
Right.
I actually, as a sales point, say, imagine that your data was organized in a file share. That is, if I hire you to come work for me, I don't want to have to teach you where every individual data point is in the business. What I want to do is teach you how it's organized so that you know where to go find what you're looking for. Right. If I tell you that production line assets are always located inside of an area, inside of the site upon which that asset runs, then you know that if you want to look for anything, the serial number, model number, the in-service date, the last time, the next preventative maintenance schedule, you know exactly where to go find that within a real-time hierarchy. So when you see a value inside of a unified namespace, that's right now.
Right.
And you can connect anything into it. I want to say one other point about that's very important about UNS. It's agnostic. One of the number one questions I get as an architect from clients is, Walker, there's 50 different predictive analytics tools out there. There's 3 big cloud providers. Which one do we use? And you want to know what the answer is? Depends. All of them. Whichever one anyone wants to use. What matters is the infrastructure. And then it matters that those tools interoperate with that infrastructure. That is the fundamental difference. Use Azure, use BigQuery, use AWS. It doesn't matter. Snowflake.
Yeah. I mean, one of the things that I like to add is, UNS is an architecture. It's not an end-all, be-all. Garbage in equals garbage out still applies to UNS. So think about your data architecture and how UNS fits in it. Because what you do with your data, how you structure it, what you make available in the UNS is going to enable the applications, whether that's in the cloud, whether that's Snowflake, whether that's being done at Litmus or HighByte, whatever platform that you use, you have to still think about your data architecture that lands in UNS.
Yeah, I have a follow-up question for this, which is, we talked about ISA 95, but when people start to construct their first UNS, how do they go about creating that structure and deciding how they break down cell, line, machine, operational data, sensor data? That is an extremely costly or maybe scary task to take all of this data that's been separated in different systems and put it all in one place together. So what are some tips for kind of first steps approaches to set a good plan so that you don't end up with garbage or inconsistent data in your UNS?
Well, the beauty of UNS is that it's flexible. So if you get it wrong up front, that's not a huge deal, okay? But I often tell customers that the best place to start is one asset, an asset, and organize it the way the ERP organizes it. So what you really want to do is you want to go to the ERP and you want to look at that asset lives somewhere. It lives in CMMS, has an asset ID in the CMMS, it's got an asset ID in the ERP system, it may have an asset ID in the manufacturing execution system. But what you want to do is look at how the ERP organizes the business. Everybody asks me, why ISA 95 Part 2? Well, because basically every ERP system uses
it's already there.
It's a good start.
It's a good start.
Great place
it's a good
to start.
start. Yeah.
So, but I mean, for example, I have businesses that are not entered, that all of my businesses run on UNS. In fact, I was going to show you how I run my businesses while I'm all over the world. And we do it through one common digital infrastructure, 49 companies. I can look at every single event, every KPI, everything all at once. And I can run 49 companies with 20 employees. But the reality is that how you semantically organize doesn't matter as long as you define how you semantically organize. That's what matters.
Yeah.
We start ISA 95 Part 2 because it makes sense.
I think it's highly logical of how a manufacturing plan is laid out. And to go back to your point earlier, you can just say to someone, look at this structure, and they can, because site, okay, everyone knows what the site is, area, line, cell. It's very logical, and so you can find the data structures there. To build on what you said, Dylan, and similar to what Walker would say is, you start with the problems that you're trying to solve and define the data structure and organize the data structure, and you start with one, and then you build up from there. So when I talk with people, I say to them, in a factory, you have 3 core data structures. You have assets, and those are what we use for like predictive asset maintenance. You have lines or process. You have processes, could be a line, could be a cell, and you have you've got assets, you've got lines, and you've got products.
Yes.
So when you think about like a batch, that's a product. You think about a serialized item, that's a product. And if you think about those and where you want to collect the data in the structure and how you want to collect the data about those key structures, then you get going, because those are really the key structures. Sometimes we want to collect data very much based on when is the batch completed in an area. Sometimes we want to collect data on predictive maintenance for an asset, or sometimes it's the process and what are the metrics that we're trying to measure. And so thinking about those are key structures in a factory, and then I want to collect data on them is a good way to start.
Yeah.
That's good.
Yeah, it kind of hints upon what John just said, is building a solid data backbone for your enterprise, whether you're starting with a single use case or with the enterprise data in your mind. UNS is a great way to converge all your data and make it accessible to enterprise applications. Like we say at Litmus, software is never a challenge. It's how you leverage the software within your data strategy that really differentiates software from a strategy.
Yep. If I can just add, let me just do an example, right? So this is a tier 1 automotive manufacturing customer, which are completely decentralized, meaning each factory is its own business. And they have their own way of organizing data. And within ISA 95, each factory has their own way of organizing the data. And the use case was like, I need to monitor the energy usage of each of the factory more efficiently. And I want a unified namespace of having a common way of doing it, because I have this application that needs to monitor it, and the KPIs need to be common. And I cannot use like different ways of organizing the data. I need to come up with a similar way. So the problem wasn't that they did not have a way to organize. They had way too many ways of organizing the data. So first of all, they had to figure out, okay, amongst this, 15 ways, you talk about area line, they had 15 lines. So how can we condense this 15 lines to say 5 or 6 lines that make sense? Let's get an agreement, because again, decentralized organization, how can they get an agreement amongst these two, amongst the organization? A big aspect of it is like data governance. Okay, let's get together and figure out like what are the common things that all of us need to do? What are the things that you can do individually without without management saying what you need to do? So there is some amount of independence for you, but at the same time, there's some amount of like control at the higher level. And that's how they went about doing it. And they're still in the journey. Obviously, they're not completely done. But again, starting in some cases with excess and then coming down is also an important aspect of unified namespace.
And if any of you are looking at the virtual factory.online, you can navigate down to line 1, production line 1. There are 2 functional namespaces there. There's Edge and there's MES. And inside of MES, there are KPIs. The Edge is consuming from the asset. What we've done is we've created an organizational structure and a functional namespace called Edge, which stands for the device that controls the asset. And we only have 4 values in there: in feed, out feed, state, and waste. By the way, they're the only 4 values you need to calculate OEE in addition to standard rate. It's really that simple, okay? The manufacturing execution system is consuming that functional namespace called Edge with those 4 parameters. It is calculating OEE and TEEP and mean time between failure and mean time to repair every 60 seconds, and then publishing it back into the KPIs in MES. Okay? And if I wanted to use an analytics platform, if I want to use, let's say I want to use Litmus to integrate with Google, because there's native integration with Litmus Edge to Google, or I want to use HighByte for native integration into Snowflake, all I'm going to do is take the 2 and I'm going to bolt them onto the UNS and then stream those events into those endpoints, those smart endpoints. There's a common question. Really smart people come in here. There might be data scientists, there may be guys who are systems architects who are uber brilliant. And they're like, Walker, this seems kind of inefficient. Why is it UNS is the architecture that works when all these really brilliant people at Microsoft keep failing? And by the way, they do. Over and over and over again. Azure failed. That was a $10 billion failure, the Azure IoT failure last year. And everybody at Microsoft is brilliant. Why is it failed? The answer is digital fluency. Digital transformation doesn't start in the data center, it doesn't start in the boardroom, and it doesn't start in the IT department. All those people need to get out of the way.
Right.
Digital transformation starts on the plant floor. And operators don't know what JSON is. Okay? They don't know the difference between a transaction and an event. They can follow a file share. And so that's why this works. UNS works for the really smart people, and it works for the people who are still working on their digital fluency. That's why it works. It makes sense.
Yeah, operators and process engineers are not database scientists.
Right.
Right.
Absolutely. I've got a question that's a bit more technical, but I think I've heard differing opinions, and so I'm curious to hear some takes here. UNS is fundamentally event-driven, but there's lots of valuable data, both contextual and at rest and transactional data that also exists, in a shop floor environment. How do you marry those 2 together so you don't end up with a fragmented data system?
I'm happy to take a shot, take a swing at it.
Maybe I'll ask John first if you have an idea.
It's a very common question.
So I see UNS as, sometimes I'll say to people, there's UNS, capital U, capital N, capital S, which is often a MQTT broker, and people can subscribe to that data. But there's also unifying a namespace. Every system, whether it's Tulip or Snowflake or S3 or MQTT brokers, have a namespace, and standardizing it, organizing it, semantic definitions, creates a UNS. So event-based data is extremely powerful, but historical data is also extremely valuable, and transactional data is extremely valuable. I think the key is you define those semantic models, you define that hierarchy, and then you apply that to any system that has the data or any access pattern that has the data. So if you want event-based real-time data, you use MQTT because that's highly scalable and one of the most powerful technologies for that. If you need transactional data, REST APIs are a great mechanism for that. If you have historical data, you probably have it already stored in a system. You could use REST APIs again to make requests on that. data. So, we see UNS as a great concept in architecture, but it doesn't have to be a single broker for the entire company. There are lots of mechanisms. The key is to structure and standardize the data.
Here's let's use the common use case of event from a machine, a result set from a REST API, and a result set from a time series database. Right? Those are three different types of data. They can live in a unified namespace together, but the retrieval of the time series event is the event. The event itself isn't all of the sub-events that make up the result set. It is the request I made for the result set and the result set hitting the endpoint. That's the event part. Everything else is retrieval. The same thing with a REST endpoint. We build REST endpoints in UNS all the time. So all of the parameters that go into post and get and result and parse, those are parameters inside of a unified namespace. So, but I'm still hitting the endpoint to retrieve the data, but we're putting those parameters in a UNS so we can still track the event that the retrieval took place. And then there's one last, which is descriptive namespaces. You are only born one time. The event of your birth happens at birth. It never happens again. But I may want to retrieve your birth 1,000,000 times.
Right, because I need it for some use.
And you can put that in a unified namespace, and based on quality of service and retention, any client upon connection will be informed of that event that happened way in the past. So John nails it, which is UNS is not in any one place and it's any one thing. It is omniscient and omnipresent.
Right.
And it's hard to, people get it. The light bulb always comes on. We were just talking, Mark and I were just talking about that. The light bulb comes on, and when it does, you go from here to here. You go from 0 to 100 miles an hour.
Right. Yeah. In some ways, I equate it to like a library index card, right? So you have a library and you have all kinds of books. You want to be able to see which book do you want and which is out, which is checked out, which is checked in. The book is actually not stored in the unified namespace. It is other places, but like the reference to where the book is, that is a unified namespace. And to me, it's like you have things coming, real-time information coming in from devices, processes, other types of information coming in. The output event is a combination of all of this, and that's what unified namespace is. So it's not just one set of data, but multiple data coming together to make sense out of all of these things.
Right.
It's also, I mean, just to tag along, I mean, great comments here from the team, is the relevancy of how you want to use that data and where you want to. Unified namespace can be a central instance for the entire company, or they can be broken down to, let's say, in our customers' cases, individual plants, because they want to leverage time series data in a unique way than, let's say, the enterprise, where the enterprise can only receive some events or aggregated data, whereas the plant level can actually publish data on a per second or sub 1 second interval for applications that need to consume that information locally. So there's multiple use cases and multiple instances of UNSs that you can deploy. So don't confine yourself to a single instance. You can leverage UNS in whichever way, but let's make sure that whatever hierarchy that you set up at a plant level and an enterprise level, they jive with each other.
Yeah,
I think you bring up a really important point, which is we're not building UNSs to build a UNS.
Right.
We're building UNSs so that people can get access to data, to make better decisions. So we often start on the upside or the downstream of the UNS. Who's building applications and what applications need access to data and how do they need to acquire data, and then work your way into the UNS as this central aggregation point, and then work your way into how do we source the data and structure it into the UNS. So what we've seen, one issue that we have seen is that people put all this effort into building the UNS, and now they've got this beautiful UNS, and they realize that the IT team doesn't have any, they built it in MQTT, and the IT team is not using anything that has an MQTT client on it, and then they've got this big gap between the two.
Yeah.
So, it's important to think about how we're using the data, where we're using the data, what is the technology of choice of the IT and of the business, and then figure out how we can link that up to the UNS.
I want to just chime in on a really important point. I want to make sure we don't miss this one point, which is this. For how many in here are like end users? That is, I'm an actual end user. I work in a plant. We do manufacturing. All right, it's not many of you. How many of you are consultants? You work for the end user. All right, and then what do the rest of you do? You're just shy? Or?
Technology providers. Technology providers, yeah, maybe.
Here is the thing that no one wants to hear. You are much dumber than you think.
Ooh.
Like you are.
So that's why they didn't put their hand up.
Right.
Because
You don't know what you don't know. Right? And one of the things about architecture, this is the most important thing about Unified Namespace. This all started, this movement was, I want to predict the future. Why is it manufacturers even care about digital? And the answer is they want to be like Tesla and Amazon. Amazon owns the world because they predict what you're going to buy 6 weeks before you buy it. You don't know that, but they know that. Mm-hmm. Tesla has a cycle time of 36 seconds per car versus Toyota's, which is north of 60 seconds, and Ford's, which is north of 60 seconds, even though they had a 100-year head start. And everyone wants to know, how is Tesla doing it? And the answer is they use data to optimize their processes natively. Mm-hmm. Tesla is smarter than Toyota. Amazon is smarter than Walmart. And I don't mean in their brain, I mean collectively as an organization. Unified Namespace as an architecture future-proofs you. There are things you don't know now that you will need 5 years from now on your journey. Like, for example, contextualization and normalization of every single event in your business. For nearly all of you, what I just said was Chinese. Contextualization and normalization of data is Chinese to you. If you don't have it, you cannot train models to predict the future. You can't learn from the data without complete context, the relationship between this data point and this outcome, no matter what it is, not a hypothesis you came up with, a hypothesis that exists. And without normalization, you can't train the model. What is normalization? If I've got an OEE calculation that changes once every 2 minutes, and I have a temperature sensor that changes 60 times per second, before I can train a model, I must have a one-to-one relationship for every change on the sensor. So for every 60 changes per second, I have to have an OEE calculation somewhere to train. That's normalization.
Right.
Most of you don't know that that's a problem you're going to have in 5 years. And if you go the digital thread route, you go the ETL route, you go the route that most people are trying to tell you to go, you have painted yourself into a corner. We call that technical debt, and you will have to undo all of it. Mm-hmm. It's a thing we don't talk about enough, I think, about Unified Namespace, is that it's an architecture that future-proofs you.
Yeah, that's right.
That is specifically the challenge, right? Because it's not really about sending data, but do you first have the data? Secondly, do you have the data ready to be consumed? Right. Thirdly, do you know what you want to do with this information, right? So you got to figure those things out first before you can even start setting up a UNS, because what are you going to do with a UNS if you don't know what you're going to do with your data?
Yeah, but there are a lot of people who say, I want a UNS, right?
Yeah.
How many people are calling you, I want UNS? Yeah. And what's the first thing you say? Well, what's the problem you're trying to solve?
Right.
Yeah.
We don't know.
It's a means to an end.
Right. Start with the problem.
Yeah.
Start with the problem.
Yeah.
Hey, this is getting a little too serious. So let me ask a question, right? So why is a UNS a relationship manager or a marriage counselor? Why do we feel that? Because it helps improve the relationship between IT and OT that are coming together either like by force or have to come together, the marriage between IT and OT. This is a relationship counselor, right? That's what UNS is.
I think I think Ravi is the relationship counselor.
Oh, boy.
We're all just helping him out. The broker is the... Yeah.
I'll take that role.
No.
All right.
Yeah, it's also that UNSs, or at least versions of UNSs, haven't existed. I mean, you can look at a historian and a tree structure within an historian, that's a UNS, but it's locked in.
Right.
The data is not structured. You've got timestamp, you've got tag name, you've got value. What are you going to do with that?
Yeah.
There's no context. So that's why historians are going out of fashion, because there's just not workable data within an historian. Yeah. So that's why you need a UNS, but you still have a middle layer to figure out how are you going to get your data, how are you going to structure it, how are you going to report it to a UNS.
Yes.
So those are some of the foundational challenges that we see within our customers.
Yeah. So just from a fun perspective, I've I was at a conference earlier, and there was a historian provider which is very famous. Everybody knows about them. They claimed that they have the unified namespace, and I had a chuckle out of that.
Right.
You cannot have a historian be a unified namespace because it's just one set of data.
That's right.
Yeah.
But the funny thing about historian, the historical question comes up. What do I do with historical data in a UNS? It's very simple. A historian is a consumer of a unified namespace.
Yes.
That's all it is. It's a consumer that you go and retrieve the history of the unified namespace, or the UNS itself, or an individual data point, or an entire model. You go retrieve that from a historian. But as we see, cloud technology is becoming more and more incredible, getting cheaper and cheaper and cheaper. I mean, I'm sending 1 million data points per second to BigQuery right now across all my companies. 1 million data, and my bill is $11 a month.
That's not bad.
Think about that.
Futures here.
$1 million, 1 million points a second, $11 a month. 5 years ago, $150 a month, right? And what's happening is history is going to the cloud, and historians are going to the edge. They're going to the edge, and they're consuming super, super high-speed data, and you're doing the analysis on super high-speed data on the edge with historians, but you're analyzing the history of your business in the cloud.
Yeah. I think traditional historian providers are being replaced by time series databases that can do the job much faster, much more efficient.
Yep.
100%. I mean, I still think that you still tie some sort of a database to a UNS, whether that lives locally at the plant level or whether that lives in the cloud. You still need a historical repository of all the data that ever existed on a UNS.
Right.
So to move on to another question, we talked about people who see a shiny new thing in tech, a UNS, and they say, hey, I want that. And they call you up and say, what's your problem? What are some good initial use cases that people should think about and how they can prove this out? Because what I see, a lot of people who come in and are talking to me interested about this, they already have some rudimentary fragmented form of, event database data, or they're polling OPC UA, or they have some, database they're querying. And maybe they can't convince their, IIoT leads to invest because there is a significant initial investment in building, governing, and deploying one. What are some good early wins that someone can think about?
I'll do the most common one. I just sold my integrator 10 years. I can tell it now. Our annualized growth was 50 to 75% year over year. We did thousands of projects, 228 primary clients. 95% of the time, the first use case is always the same. It is, I want to monitor current state of my assets, and I want to measure the efficiency of my assets. So generally it's, I want supervisors to be able to monitor, and I want operators to know how well they're doing.
Yeah.
So OEE calculations, that's by far the most common use case. It's unlocking the potential of those events inside of the asset and converting that into business information so that we can make better decisions. And it's generally one asset, overall equipment effectiveness, TEEP, mean time between failure, and mean time to repair.
MTTR, yeah.
Yep. That's the most common first use case in my opinion.
I agree, but I'll challenge and say, what's the second? Because I think a lot of companies already have some rudimentary form of OE. So if they're having any sort of data that they're pulling through, Kepware or whatever, that's the first thing. So how else could they show value to prove the utility?
Just if I can just chime in there, right? So to be able to do that efficiently, to be able to do OE or mean time to repair, they need actually the data from a lot of across the enterprise, which they're not doing, right? So they're looking at specific machines and looking at MTTR, but then that doesn't give them the full picture. With the UNS, they can actually pull the data from all of the different sources that they need and get a true OEE or true MTTR that they can report on, which matches with their goals, right? So I would argue that, starting with that and then any kind of condition monitoring that will give them the current state, and then building on that to do like any advanced applications. Like, of course, we had to call AI out.
No matter what you do, you're always going to do the same 5 things in the beginning. Connect, collect, store, analyze, visualize.
Yes.
Connect, collect, store, analyze, visualize. Connect, collect, store, analyze, visualize. UNS is designed to connect, collect, store everything so that all you're doing use case after use case after use case is the conversion of data into information for analysis and visualization. Visualization sometimes is consumption by other applications. It's not a human being necessarily analyzing. If I'm going to hit a REST endpoint, that is visualization. It's visualization for software. But it's almost always collect, store, analyze, visualize. Sometimes it's, this is great. I know the efficiency of this asset, but I really want to know the efficiency of this asset in relation to our product codes, our operators, our work orders, our raw material vendors, and that requires ERP integration. So maybe second time, now what we're doing is we're adding in ERP context to a use case that we started with. But it's always connect, collect, store, analyze, visualize, and then down the road, we find patterns in the data, we report the problems that we find, and we solve those problems.
Predict, predict failures.
I think also to build on, production metrics.
Yep.
Agreed, 100%. Predictive asset maintenance, another key one. Quality, which is really probably a production metric, but a lot of people call it out independently. Sustainability, which, sustainability is coming on very hard, and it's kind of, could be power consumption, could be waste creation, could be lots of different things, and you could also look at it across the different dynamics. So you could look at it as, what is my power consumption of an asset? Other companies want to look at it as, what is my power consumption of a model that we produce, of products? Because they want to know, right now, they get the power bill and they just spread that across all of their product lines. And what they really want to know is which product lines are truly profitable and which ones aren't. And to be able to put things like power consumption and things like that on an individual product model and structure that data enables you to just get access to so much more information to drive decisions. So, I go back to products, process, and assets, and everything kind of falls somewhere around there.
The summary, and I think Litmus guys definitely agree with this one, because what I see with the customers that we're using Litmus with is that it's about coming out of the dark into the light. Like, that's the description. There is some problem in the business that they know they have, but they can't articulate it because they don't have the empirical proof to analyze and determine. This could be something like, our power bill is too high in the compressor room. We're spending too much money on the compressors. Sometimes it's that simple. Sometimes it's, wow, third shift really, really underperforms. Right. And I'm not coming in to babysit on third shift. And so why are we underperforming? I mean, I can see that maybe we think we're generating a little too much waste. Most of it is coming out of the dark into the light. The answer is always, it depends. Every time someone says, where do I start? It depends.
Yeah.
I mean, Galad's going to tell you, it depends. Anybody who lands there, Mark's going to tell you, it depends. Somebody who has experience doing this has to put feet on the ground. And they have to look at things from a 10,000-foot view, a 5,000-foot view, a 1,000-foot view, and make a professional opinion. I think we should start here.
And you're getting all philosophical. You're saying it leads us from darkness to light.
Yeah.
That's philosophical.
Yeah.
Yeah, I mean, folks could argue that we've been doing predictive maintenance. We've been doing all these use cases without UNS thus far. Why do we need a UNS, right? So first of all, I think foundationally, as an enterprise, you have to agree that that is going to be our mechanism of data exchange. So first and foremost, fundamentally, the organization has to come to an understanding that we're going to communicate using UNS and the standard methodologies within that. Once you establish that, you can build any use case on that, because the challenge in manufacturing isn't UNS, it isn't software, it's a data foundation. Lay out your data foundation and then build a UNS on top, and then you can build any use case that you want to.
I would challenge everybody here who hasn't done this already to go over to Mark's demo over where in the life sciences facility there. I think it's three cells together. Mark built that over the weekend. Had never built a unified, right?
Not all over the weekend.
Right, but he's never built a unified namespace before. What you should do is go over there and watch him walk you through what the value. You tell me what the value of unified namespace is after he shows you how it works in that application, because you'll see it. You will see the events interoperate with one another. And if you're ever been a person who's done ETL, the light bulb comes on. We hired a data scientist straight out of college, just finished his PhD. He comes in, I pitch him unified namespace. He's in the conference room, 27-year-old kid, his mouth is wide open. And he says, wow, that's why ML and AI applications fail. Because that doesn't exist.
That's exactly right. And
Yep.
a lot of the things that we see in the marketplace. A lot of the surveys agree with that because, I mean, companies invest a lot in AI without even understanding what they're going to do with it, and then they find that they have a data problem. They have data quality issues, they have inconsistencies in the data, and projects stall because I'm not going to adopt something that I cannot trust.
Right.
Yeah. Right.
I think to Hari's point earlier, you have had access to data, but the resolution wasn't what you really needed. You were getting reports once a week. You might even be able to get access to data once a day, but it was yesterday's.
Data.
You had it for a specific machine. You could always send an intern down to stand beside a machine to count when defects occurred. Now, if you could have it across the entire factory, all of the assets, all of the data in real time, and then you could roll that with standard data sets across your entire company. Like that's mind-blowing to most companies.
And then maybe using that, we can build some LLMs that will do the counting,
right?
And not the poor intern that has to do that.
Yeah, I mean, well, we need to automate the collection of the data and then push it into the UNS in a standard way so that a quality engineer who's at corporate can look across all the lines across all the sites and get access to that information. That's where people are wanting to go. That's the excitement. And that's where I think they can go today, because we need to govern that, we need to standardize that structure, we need to utilize the structure, but it's all available.
I think this demo you're plugging that we built this weekend, it really shows the circular value of a UNS, right? So you can take operator and machine and data, sensor, contextualized data, send it up into a space, put it in a cloud data lake, build analysis on top of it, generate insights, and then send that back down to the shop floor, to the places where it can be actioned to actually generate value. Because all of the value really happens on the shop floor, right? It happens with the supervisors, with the workers, with the maintenance teams. Mm-hmm. So getting them the right data is where this is really.
And Mark even acknowledged, he said, I had a time crunch. And he said, if I didn't have a time crunch, I would have extracted the data directly from the instrument myself, but because I had a time crunch and I knew that the data was already up here in HiveMQs in the UNS, which was actually living inside of a broker at the time, he said, I just went and got it from the broker itself. Awesome. And that saved me the time. One other thing I want to plug Tulip here, and obviously unsponsored, but everyone has asked me, why is it Tulip is the only platform developer why are they ahead in generative AI? And leveraging LLMs embedded in the platform. If you don't know, you can use a chatbot to help build an application. You can tell it to create a component for you and drag it onto the screen. But more importantly, you can use a chatbot to analyze the underlying data. Like, for example, I'm having a problem with this printer. What is the likely outcome? And it goes and it searches all of the past incidents of a printer problem and says, why don't you check the ribbon, check this, check that, because on this date so-and-so had that problem, this date so-and-so had this problem. The reason they're ahead is because under the hood, in every Tulip instance, is just an Airtable which is semantically organized and all the events live there. There is a namespace underneath the Tulip platform. And because that namespace exists there, they didn't really have that much work to do to build the chatbot. I mean, the truth is they laid it on top and said, that's what you're going to go learn from. And at the end of the day, if people aren't there yet, their fluency isn't there yet, their maturity isn't there yet, how do you make the case for that from an architectural perspective if they can't appreciate it? And the answer is you don't. You start with an architecture that works for both problems, the simplest one they have right now and the one they're going to have in 5 years. And that's one of the things that UNS does.
Yeah, composable architecture.
That's right, composable architecture.
All right, so just maybe one last question, or we can open up to the audience. But I was just wondering if you guys have seen any, specific industries that are starting to take to UNS more quickly, or specific use cases, and why.
Hold on. I'll let you.
Industry-wise, we've seen it across all industries, really. We have customers, anyone from an automotive OEM to industrial products, pharmaceutical, food and beverage, oil and gas, really spans discrete, batch, continuous processes. And so we don't see it as unique to industries. We see it as unique to companies that are trying to digitally, drive their business digitally. And that those are the people that And unfortunately, it's actually companies that have tried that for the last few years and failed.
Yeah.
And then they find UNS, and then we can accelerate them. But it's not so much industry focused from our experience.
Yeah, Yuri's presentation last year, Yuri Bagnode from Cartier gave an outstanding presentation last year talking about all the things he did wrong, what they did wrong for 10 years before they saw the light. And Yuri is a huge evangelist of Unified Namespace. Yeah. But to John's point, it is everywhere. If you want to know industry-wise where I think what's the differentiator, the people who own all of their data, they're the faster adopters. Like if they don't have to get permission from a vendor who owns something inside of an asset or whatever, they are much more likely to adopt very quickly. That's why you see, Ford laments, hey, we lost because we outsourced the ownership of our data in the electronic control modules to Bosch. We don't own it.
Yeah.
So if we want to use data to improve our processes, we have to work with Bosch to do that, whereas Tesla doesn't. The fastest grower right now, absolutely 100% is life sciences because of Regeneron and because of Stata in Europe. They did a huge presentation on UNS and all things in life sciences. As soon as one person proves it, they all adopt it. So that's the fastest grower, but they were the laggard. Food and beverage is a huge one because they run on such razor thin margins. And I would say food and beverage is a really big one, but John's right, it's everywhere. I mean, it doesn't discriminate. By the way, oil and gas funded most of this. Phillips 66 was the first to the ball, honestly, in oil and gas. So
yeah, that's where MQTT started.
MQTT
in 1999.
Phillips
66, yes. Just to add to what both of them mentioned, just looking at the company size. So obviously, from a variety perspective, completely agree, right? So from a company size perspective, obviously the larger companies are the ones that obviously over time they have kind of created a beast for themselves, and then they have data sitting in all these different silos, and they're the ones that really want UNS to really help them out. The smaller organizations, I think they kind of do things right from day one, so they have the building blocks of UNS, so they can easily adopt it. But really, the company size, UNS is mostly needed by bigger companies. That's what we see. Harry.
Yeah, likewise. I mean, we see bigger companies adopting it because more cross-functional teams that need access to that information, whether you have data scientists, whether you have plant engineers that access that data, or IT teams that need access to any sort of event-based information. Those are the companies with cross-functional teams that we see adopting UNSs across the board.
Yeah, and just on life sciences, it's interesting. I remember having a conversation with one life sciences company, and they basically said they go with so many different OEMs within them that the OEM is not willing to give us the data. They say that we have to go to their cloud solution and purchase a package to get our own data. And we're like, screw this. I'm going to build a UNS. I'm going to draw all the information. I'm going to try to get my own thing. Right? That's ludicrous that they cannot get access to their own data.
I want to challenge you guys to do something. I go to a lot of shows. I speak a lot. Last year was the first time I ever came to a conference. This show was the first conference I ever went to where all the vendors were integrated together in the poster session. And that's where the idea for our conference, Prove It, in February, came from. It came from what I hated about Hanover Messy and what I loved about Operations Calling. And we created this conference called Prove It, where vendors are going to come, and actually I think everybody here on the stage, HiveMQ, will actually be the broker. They're coming to Prove It, and we have a virtual factory that every vendor is going to integrate to. They're going to build solutions for one food and beverage client over 16 weeks. And the whole show is that, right? Well, I want to challenge you something. If you go to the poster session here right now, and you ask every vendor, I see your features and benefits, I know what you're selling. But let me ask you this question. If I buy from you, and I buy from him, and I buy from him, and her, and her, and her, how do you all talk to each other?
Right. Yeah.
How do I unlock the data in all of your solutions and put them together? They're all going to tell you Unified Namespace. Then I want you to go to another conference, and I want you to ask the same question. And you will be stunned at the number of vendors who don't have an answer.
Right.
They'll say, oh, we have a API, we have a, the answer is a lot of money and a bunch of engineering.
Yeah.
Unified Namespace is designed to make agnostic vendors plug and play. That's just one additional feature of it.
Yeah, and we're very proud of our partner ecosystem, and very glad that you all came here. So I think that's...
So it's a nightmare for custom application developers.
Yes.
Yeah, they're going to be out of a job.
Yes.
All right.
Good last point. Okay, I think that's a wrap here. We have maybe 5 minutes if there's 1 or 2 questions from the audience. Anyone wants to?
This one there.
In the tie-dye shirt there? Or striped shirt?
All right.
Rainbow shirt.
Hello, testing. Oh, there we go. Before I start, I just want to, if you guys can give it up for the setup crew. It's a lot of effort to put this event today. So if you haven't already, give them a shout out, give them a thanks. Much love to y'all.
It is. Thank you.
Oh, very nice.
I really just have 2 questions. Now, I thought about the best way to approach this, and I think because everybody here is so in tune with Tulip, I wanted to point out that Tulip uses 2 very beautiful open source technologies, one of which being React, one of which being Node-RED. And I would love to see why anybody would ever think open source is not important or in any way a prerequisite to any sort of digital maturity without having open source. The second question I had is when somebody goes and protests on a public sidewalk and addresses an industry association that is known very well for having some of the top leadership that is so heavily against open source, and on 2 separate occasions threatened to put a protester, peacefully by the way, with donuts and bagels, I did not bring the cream cheese, threatening to put them in a cage. Do you think that's a good look? Do you think that sends a good message for people that might be either interested in learning for open source technology or even just engaging in a broader conversation around technology?
I'm happy to be the controversial one.
Please.
Yeah, so number one, when it comes to open source, I'm a huge advocate for open source. The problem I have is the prerequisite. Open source is not a prerequisite for digital transformation, but it is incredibly valuable. It is not required. It is possible to go with a completely closed proprietary stack that supports an open architecture that will plug into a UNS. It is possible. It's probably not recommended, but it isn't a prerequisite. Open source, though, I am a huge advocate. I would say open source we all use, but it is not a prerequisite.
Yeah.
On the protest thing, I think I understand it. No, I think if I believe in the free exchange of ideas, no matter how big of a jerk or obnoxious somebody is, and I think you should engage until they're no longer reasonable and then block them. That's what I think.
Right.
Here.
Yeah. So
there's certainly on the open source side, I mean, the technologies out there are awesome, right? We've had amazing software that's comes out of open source ecosystem. The challenge isn't really the software. It's about whether you're creating a technical debt for yourself when it comes to an enterprise level deployment. So take, for example, Node-RED. So if you're deploying Node-RED under Raspberry Pis on your plant floor, how are you going to scale to 50, 100 plants? How are you going to manage that debt? How are you going to make sure that logic that you're building for one machine in plant number A is also replicated in plant number Z? And how are you going to manage the scale aspect? So open source as in is not a challenge. It's scaling open source and making that available and relevant across the enterprise. That is the real challenge.
And by the way, here's a practical example. I want to use Node-RED, fully open source. I want to pay anything for it. I'm going to download Joe Schmo's MQTT client. There are more than 30 different MQTT clients, packages that were developed open source by other people on Node-RED. And the vast majority of them cannot handle more than 10 simultaneous connections to an MQTT broker at the same time.
Sure.
If you do the 11th connection, the previous 10 all disconnect. Right. Now, who are you going to yell at when that takes down your production infrastructure? So while I use Node-RED in a development environment, and I certainly use it as a force multiplier, but the real question is, okay, when I get into SLAs and I've got an agreement with a client and I'm on the hook for $10 million for every 10 minutes they're down because it's my fault, that is a huge chance to take when there isn't someone else who is financially responsible for the damages. Because in open source, by the way, you are taking on all of the risk when you use open source. The developer is under no requirement as part of the licensing. There is no risk that they assume. So it's those types of things. You have to answer those questions, and you weigh. Your actuary will weigh and say, yo, no, that's a risk we can take. Or no, it isn't.
I think you're also looking at, so I agree, scale, support, You also look at the speed at which products are being evolved for your specific need. And so, we all are using some level of open source in our solutions, but we're adding a lot of technology on top of that open source, and we're doing it specifically for manufacturing, specifically for deploying UNS, standardizing semantic models, structuring, delivering data at scale, governed, high quality, with observability, with the pipelines that you need, the orchestration that you need. So if you see value in that, we think that the value that's being delivered in that far out exceeds the cost of using software that you can purchase from any one of the vendors on the stage here today.
Hey, who here has heard of Mosquito? You heard of Mosquito Broker? Okay, now watch this. How many of you have heard of Sadalo? 2 of you. Right. Sadalo is the paid version of Mosquito.
Right.
It is Mosquito Pro. Though all the Mosquito that you guys use for free, there is actually a commercial version of it that basically no one buys. I think it's 0.0, I think he told me Phil said like 0.06% of all installations are paid installations. I believe you're going to use open source. And Henry, keep doing what you're doing, man. Keep pushing, all right? I think what you're doing is very important. The simple reality is this. If you're going to use open source, okay, and you convert open source into value, you have a responsibility to pay.
Yes.
You have a moral responsibility to pay. If you are converting open source into commercial value and you don't pay, I want nothing to do with you. That means you lack values if you're doing that, because someone did that work. And if we want the open source community to thrive, we have a responsibility to pay our commercial value forward to the developers who develop that open source software. Yeah. All right,
Sorry, just a last point, I guess. So we are obviously based on open source. HiveMQ is an MQTT broker. We've taken the open source MQTT and added scalability, added like reliability, because we realize that in an enterprise situation, you need the 24/7 support, you need the scalability, you need the reliability that you need. But we also have an open source version similar to Mosquito, right? That obviously customers can use, but they have a path to get to a more commercial solution depending on their use case as well.
Yeah. So. Great. Okay, that's all the time we have for now. Thanks everyone for joining. Thank you.
Thank you.
Yes. Round of applause.
Thank you. That was awesome.